This is an NVIDIA H100 graphics processing unit, a piece of silicon roughly the size of a playing card that contains 80 billion transistors, costs $40,000 at retail, and is currently the most sought-after industrial component on Earth. Every AI model you've interacted with, ChatGPT, Claude, Gemini, Copilot, was trained on clusters of these chips, each cluster consuming enough electricity to power a small town. 2 years ago, this chip didn't exist. The H100 launched in March 2022, designed for the data center workloads that were supposed to grow steadily over the next decade. NVIDIA planned production capacity accordingly, a few 100,000 units per year, maybe scaling to 1 million by 2025, enough to serve the hyperscalers and the research labs and the enterprise customers who needed high-performance computing. Then ChatGPT went viral, and the demand model that governed semiconductor planning for 30 years shattered overnight. Microsoft ordered 150,000 H100s, then another 200,000. Then committed to buying every chip NVIDIA could produce through 2026. Google matched. Amazon matched. Meta committed to building AI infrastructure that requires 600,000 GPUs by year-end. Chinese companies, before export controls blocked them, ordered hundreds of thousands more. Sovereign wealth funds and nation-states entered the market, bidding for allocation at any price. As of this morning, the H100 backlog exceeds 4.2 million units. NVIDIA's annual production capacity is 1.8 million. At current production rates, clearing the backlog would take 28 months, and that assumes no new orders, which is absurd given that AI investment is accelerating, not slowing. This is not a supply chain disruption. This is a complete mismatch between what the semiconductor industry can produce and what AI development requires. The gap cannot be closed by ramping production. It cannot be solved by building new fabs. The bottleneck exists in places the industry never planned for, and the consequences are cascading through every technology sector on Earth. Here's what they're not telling you. The H100 chip shortage is the visible symptom. The disease is deeper. AI has created a demand shock that is overwhelming not just GPU production, but the entire semiconductor supply chain. From wafer fabrication to advanced packaging to testing capacity to the specialized materials that make chips possible. Start with wafer fabrication. Every advanced AI chip, NVIDIA's H100, AMD's MI300, Google's TPU, Amazon's Trainium, is manufactured at Taiwan Semiconductor Manufacturing Company. TSMC controls 92% of the world's advanced chip production at 5 nanometer and below. There is no alternative. Samsung's foundry division produces the other 8%. Intel's foundry services are years behind and not yet capable of manufacturing at the cutting edge. TSMC's advanced node capacity is fully allocated through 2027. Not just for AI chips, for Apple iPhones, AMD processors, Qualcomm smartphone chips, automotive controllers, networking equipment. AI demand didn't add to TSMC's customer base. It jumped to the front of the line, displacing orders that were already placed, that automakers and smartphone manufacturers were counting on. At 9:45 a.m. Taipei time on Thursday, TSMC announced that lead times for 3 nanometer production had extended from 16 weeks to 34 weeks. 34 weeks, 8 months, before a customer who places an order today receives their chips. And that's for customers who already have allocation. New customers are being told 2028 at the earliest. But wafer fabrication is only the first bottleneck. The second is advanced packaging. Modern AI chips aren't monolithic pieces of silicon. They're assembled from multiple components, chiplets, that are stacked and connected using technologies with names like CoWoS, Info, and 3D packaging. These packaging technologies are what allow NVIDIA to build chips with 80 billion transistors. Without them, the chips wouldn't function. Advanced packaging capacity is even more constrained than wafer fabrication. TSMC controls 85% of the CoWoS capacity required for H100 production. They've been expanding, but packaging expansion takes 24 months from groundbreaking to production, longer than fab expansion for some processes. At 3:30 p.m. Eastern on Wednesday, industry intelligence firm Tech Insights published an analysis showing that CoWoS packaging will be the binding constraint on AI chip production through 2026. Even if TSMC could manufacture more wafers, they couldn't package them into functional chips. The bottleneck has shifted from fabrication to assembly, and the industry wasn't watching. Then there's testing. Every chip that leaves a fab must be tested to ensure it functions correctly. Testing requires specialized equipment manufactured by a handful of companies: Advantest, Teradyne, Cohu. Those companies have order backlogs of their own. The machines that test AI chips cost $5 to $15 million each and have lead times of 12 to 18 months. Then there's substrate manufacturing. Advanced chips require substrates, the physical base that connects the chip to the circuit board. Substrate manufacturing is dominated by Japanese companies, Ibiden, Shinko, that were already running at capacity before AI demand exploded. Then there's high bandwidth memory. Every H100 requires 6 stacks of HBM3 memory, manufactured by SK Hynix, Samsung, and Micron. HBM capacity is sold out through 2026. SK Hynix has already allocated 100% of its 2025 and 2026 production to NVIDIA. Samsung and Micron are similarly committed. The chip bomb isn't one explosion. It's a chain reaction detonating at every node of the semiconductor supply chain simultaneously. This is where the lie becomes unsustainable. The AI build-out isn't just absorbing semiconductor capacity. It's pulling resources away from every other industry that depends on chips. And in a world where everything depends on chips, that means every industry. Automotive semiconductors are in crisis again. The chip shortage that crippled car production in 2021-2022 was supposed to be over. Automakers planned production schedules, assuming normalized supply. But the fabs that make automotive chips have diverted capacity to more profitable AI products. A chip that sells for $2 in an automotive application generates maybe $200 in margin for the foundry. The same capacity allocated to AI chips generates $2,000. The economics are brutal. TSMC isn't going to turn down NVIDIA's orders to make $2 chips for Toyota. The foundry will serve the customer that pays the most, and AI customers pay 10 times what automotive customers pay. At 7:15 a.m. Detroit time on Tuesday, General Motors announced a production cut of 68,000 vehicles in Q1 due to semiconductor supply constraints. The statement didn't mention AI. It didn't need to. The constraints GM faces are directly caused by AI demand consuming the capacity that automotive applications require. Consumer electronics face the same squeeze. Apple's iPhone 16 production has been delayed by 4 weeks due to wafer allocation conflicts at TSMC. Qualcomm's Snapdragon chips for Android phones are on allocation. Laptop manufacturers are reporting 20-week lead times on processors that used to ship in 6 weeks. Medical devices, networking equipment, industrial controls, defense systems. Every sector that relies on advanced semiconductors is discovering that AI has priority, and they don't. The US government is starting to recognize the national security implications. At 2 p.m. Eastern on Friday, the Department of Defense published a solicitation for priority access agreements with domestic semiconductor suppliers, essentially seeking to guarantee that military applications receive chip allocation even when commercial AI demand is higher. The solicitation acknowledges what the industry has known for months. There isn't enough capacity for both AI and everything else. Someone has to be rationed. The market is rationing through price. AI customers pay whatever it takes, while automotive and consumer electronics customers get squeezed. The government is now trying to ration through policy. Less than 90 days remain before NVIDIA's next-generation Blackwell architecture begins volume production. Blackwell requires 50% more packaging capacity per chip than the H100. Its launch will intensify every bottleneck that already exists. The transition from H100 to Blackwell won't relieve the shortage. It will accelerate it, as customers rush to secure the new architecture while existing demand remains unsatisfied. While one side scrambles, the other side stockpiles. The entities that understand semiconductor constraints best are responding in ways that make constraints worse for everyone else. Microsoft's capital expenditure on AI infrastructure was $14 billion in 2024. It's projected at $32 billion in 2025. That money is buying chips, every chip Microsoft can secure, at any price, stored in inventory against future needs. The stockpiling is rational for Microsoft. It's devastating for everyone competing with Microsoft for the same limited supply. At 6:30 a.m. London time on Thursday, the Financial Times reported that Saudi Arabia's Public Investment Fund has been attempting to purchase entire years' worth of NVIDIA production directly from the company, bypassing normal allocation channels. The bid reportedly exceeded $10 billion. NVIDIA declined, but the attempt signals how desperate well-capitalized entities have become and how far they'll go to secure supply. China's response has been to build an alternative supply chain from scratch. Since October 2022, when the U.S. implemented export controls on advanced semiconductors, China has invested over $140 billion in domestic chip manufacturing. They're building fabs, acquiring equipment through gray markets, developing indigenous chip designs. They're years behind on cutting-edge technology, but they're moving faster than anyone expected. The export controls were designed to slow China's AI development. They may have succeeded in the short term, but they've also guaranteed that China will never again rely on Western semiconductor supply chains. The decoupling that was supposed to be a strategic advantage is becoming a strategic vulnerability, because China's domestic build-out will eventually compete for the same raw materials, equipment, and talent that Western fabs need. This is what a supply chain looks like when it breaks. Not physical disruption. The factories are running, the ships are sailing, the chips are being made. But structural inadequacy. The capacity that exists is insufficient for the demand that's materialized, and the time required to build new capacity exceeds the patience of markets and governments. The semiconductor industry has always been cyclical. Shortages and surpluses alternate as capacity investment overshoots or undershoots demand. But AI has introduced a step function increase in demand that the industry's planning cycles never anticipated. It's as if the industry designed a highway system for 10,000 cars per day, and suddenly 100,000 cars showed up. Not because more people are driving, but because each driver now needs 10 vehicles. The capacity that would balance supply and demand doesn't exist. Building it requires $500 billion in fab construction, 3 to 5 years of execution time, and a supply chain for construction equipment that is itself constrained. The new fabs Intel is building in Ohio and Arizona won't produce chips until 2027 at earliest. The new TSMC fab in Arizona is over budget and behind schedule. Samsung's Texas expansion faces similar delays. By the time the capacity comes online, AI demand will have grown further. The industry is chasing a target that keeps moving away from them. The shortage isn't temporary, it's structural. And the price that balances structural shortage isn't $40,000 per chip. It's whatever price destroys enough demand to match the supply that exists. Some will look at the AI chip shortage and see a problem being solved. We'll trust that NVIDIA, TSMC, and the industry will ramp production. We'll assume that high prices will moderate as capacity expands. We'll believe that market forces always balance supply and demand eventually. These are the same voices that said the 2021 chip shortage would resolve within 6 months, that said supply chains were resilient because they'd never been tested, that said diversification from TSMC was progressing when it wasn't. The voices are always confident about problems they don't understand. Others will read TSMC's lead time data. We'll track the CoWoS bottleneck. We'll count the automotive production cuts and the iPhone delays and the Defense Department scrambling for allocation. We'll understand that AI didn't just increase chip demand, it fundamentally broke the allocation system that distributed scarce capacity across industries. The informed are not predicting when the shortage ends or what prices chips will reach. Semiconductor markets are too complex for simple forecasts. What the informed recognize is that the mismatch between AI demand and available capacity is structural, that closing the gap takes years, and that in the meantime, every industry dependent on advanced chips will be competing for inadequate supply against AI customers with unlimited budgets. This is not financial advice. This is not a recommendation to buy NVIDIA stock or short automotive companies or take any position based on semiconductor supply analysis. This is simply an observation about what happens when a technology transition that was supposed to take a decade happens in 2 years, and the infrastructure designed for gradual change faces exponential demand. The H100 in a data center looks like just another chip, another piece of silicon doing computations, another component in a server rack. But that chip, and the 4.2 million orders behind it, and the packaging capacity that can't keep up, and the wafer allocation fights, and the automotive plants going idle, and the iPhone delays, and the Defense Department begging for priority. They're all symptoms of the same underlying break. AI needed more chips than exist. It still does. It will for years. The chip bomb has detonated. The supply chain is breaking, and putting it back together will take longer, cost more, and leave more casualties than anyone in the industry is willing to admit. The Silicon Age was supposed to deliver abundance. For everything except AI, it's delivering scarcity. And the scarcity is just beginning.